is supposed to be attached to here, and this diaphragm is the bottom part of the pressure tank. And if you look inside, and you see I am very well dressed for our workshop, even though I don't have an overall. You should wear some safety shoes. So inside you can see the pressure tank. This is the pressure tank inside here. And it does have some speed controls on the top. If you want to increase the size of the droplets, you can play with that. But read the manual. The bottom of that pressure tank is where the diaphragm is, and when you pump the water, because you put the spray mix inside here, and when you push the diaphragm, the water is pushed from the spray mix in here into the pressure tank, and it can't escape. So that you pressurize the pressure tank inside here, and the only way of allowing that liquid inside the pressure tank to escape is through opening the nozzle. The nozzle is here. So opening that, and if you look in the notes, you will see a diagram of this, and it will give you the different identifications of the different parts. The nozzle, the pressure tank. Yeah, so that's the diaphragm, which is separate from, that's the diaphragm, which is separate from the piston one. The piston one, it's the same principle. It's the same principle. You have but the difference is the pumping mechanism, which is different, and that's the piston one. And you can see down the bottom here, the lower part of the pressure tank is made up of diaphragm one. As you can see here, this is the piston for the piston operated one. So you can take a photo of this when required. So it's basically pushing the liquid inside the pressure tank, holding it there. You keep pushing, you increase the pressure, which wants to be released. And when you release it through the nozzle, it comes out in a burst of speed, and as a result, you spray. The droplets become smaller, and it covers a wider area. Okay. So here is what is required. Diaphragm lever operated. CP15. Record the make, the model, serial number. Then note the following essential components and respective functions. So spray mix tank. So take a photo. ID the spray mix tank, the pressure tank, the lever or operating handle, the lance and nozzle. So you can have one photo of all of those and just put some arrows. Okay. Yeah, those are the things I want to see you identify. Capacity of the tank. What is the size of the volume of the okay. It says here number 4, pour water into the tank and practice using the sprayer. You can miss that one, because we are going to actually do it outside. So forget about number 4, but you do number 5, which is Use, take or use the photo made available of the pump mechanism. Used, the diaphragm. Now, I think it would be sufficient if you can just take a photo of the bottom of the arm, but we'll take a photo of that and we'll make that available on the Moodle, so you can use that photo. And include it as part of your submitted report. So, those are the things I want you to just put in your report. Familiarize yourself with the way the sprayer components work together. Don't worry about that, just identify those things. Those are the things that have marks in the marking rubric. Then piston manual of lever operated one, the solo one, same things, make, model, serial number, spray mix tank, pressure tank, lever, operating handle, lance and nozzle. So lance is this thing here, the lance. And then take a photo, made available, or you take or use the photo made available, the pump mechanism. So we'll get, Maury, we'll take a photo of the actual piston itself, which is, that one, you can identify it. You need motorized knapsack sprayer, just take a photo, make, model, serial number. Well, it says engine specifications, speed and spraying controls, spray mix tank. So you just take a photo of the side and ID those things. Familiarize yourself with it. Yeah, okay. That's fine. Don't worry about that. What's important is our calibration one, which we are going to do now. Any questions? So find those specifications and identifications. This and that, and include those in your report. For that machine there, you probably only need just one photo and identify all those other things, one or two. What's important is the calibration, and that's the one that has the most marks. Yeah? Any questions? No questions. Okay, so there you are. For the rest of our practical, we are going to use a solo piston operated knapsack spray. How long will it take a person to spray the whole area? Calculate total volume of the spray mix. How much of this spray mix will be made of the chemical? If the spray operator is paid $8 an hour, how much he will get altogether, how many sprayer loads, and then you calculate for one, for the volumes of chemical and water for each load. If you're going to mix one load. Just in 1 minute, but then you would have to use minute as the constant. But we used the second in the class, so I think we'll just keep to the seconds. The actual that's a width one. So this is we'll measure this one as the But try and spray as if you're actually spraying to kill the weeds. So we start on now. So what's the time? 55 seconds. So round 1 is 55 seconds. 20
55 seconds.
So you are heading up.
Is
This
55
would
seconds
be
by 20 meters.
time taken to cover 20 meters. And round 1 is 55 seconds. So we'll do round 2. Round 2.
This is round 2. The first one is round 1, so now we are into round 2. So now this is round 3. Okay, this is round 3.
Seconds, 83 seconds. So that's closer to the last one, huh?
And this is our last run, which is run 4.
One minute and 16 seconds.
1 minute and 16 seconds. So that's 76 seconds. 60 seconds for the minute.
What's the time?
76.
Run 4 is 76 seconds.
You end up with meters per second.
76 seconds. Hey, you come here.
20 meters, whatever the number of seconds, and you work it out, you should get the answer the value in meters per second. So now we, where's the end of the tape? Bring the tape. Take up the
1 meter and 30,
1 meter 31
centimeters.
No, 3 decimal places. We will get you to read the tape better when we do the mapping.
1.3.
Somebody read it to 3 decimal places if you can. Which will mean it will be in meters.
1.3 meters.
It can't be exactly that. Okay. 1.3. Yeah. Well, it's actually at zero. Let's say it's this one here. This one. Yeah, this one. Huh? 1.302. Because that's this one here. 1.31. 1.310 is that one. But I'm saying we come up to here. It's not yet up to 1. So 1.302 because each of these is 2 millimeters. So let's make it 1.302 decimal numbers rather than counting the number of centimeters, the number of millimeters. So 1.302 is the effective spray weight.
Okay, we have 3 runs. Run 1, the time is 55 seconds. Run 2, which is 83 seconds, which is exactly 1 minute 23 seconds. Run 3 is 83 seconds. Run 4 is 76 seconds. And the width is 1.302 centimeter meter. 1.302 meter.
So pump first so that where's our timer? You are okay. Pump so that you get the right pressure. Put the spray inside here when you start. So when you start, you tell her start.
Wait, 1, 2, 3.
Yeah. So 30 seconds. So we're keeping the time constant. And you tell him when to stop. Who wants No. So now you open the Oi. Of the volume, so the volume will be in mils. 500, 800 mils, 900, 1,000 mils. This is 1 liter. 1,000 mils is equal to 1 liter. So pour it back in.
No, one.
I don't think we need this. So I'm just going to estimate. Okay, now this is 100 mils. From here to here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these is 10 mils. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 100. So each of these lines here represents 10 mils. So that's 10, 20, 30, 40, that's about halfway, 45. So I would say this is 145 mils. Plus the
145 mils.
So that's 145 plus 1,000, 1,400, 140 mils. You can work in liters if you want, which would be 1.14 liters, or you can work in mils, 1,400 or 145 mils. Okay? So that's run 1. Run 2. Timer. So if you had a container 1 meter, 1 meter, 1 meter.
3, 2, 1.
This is 1 meter by 1 meter by 1 meter. The volume would be 1 cubic meter, and it will take 1,000 of these to fill it. Okay.
is 1 liter. Round 2 is 1 liter.
So that's 800. That, wait. This is 90. Make it 90. 90 mils. So 1
1,000.
liter, 90 mils.
1 liter 90 mils.
1,090. Yeah. 1,090 mils
1090 mils.
for 1 liter and 90 mils. For 1.09. It's not a 1.9, it's 1.09
1.0.
liter if you wanted to work with liters. That's why it's better to keep to mils. Otherwise you get confused with the decimal. So it's 1 liter and 90 mils.
1 liter and 90 mils. For round 2.
Yeah, third run coming up.
Round 3.
3, 2, 1.
Round 3.
To go through the exercise of using Excel to calculate this problem. This is run what? 3.
3.
Round 3.
1 liter. Yeah. 10. Oh, this is 5. This is so this must be 40. 40 mils. 40 mils. So 1 liter, 40 mils.
1 liter 40 mils for round 3.
Yeah. And last one.
Last round. Round 4.
Shared in 30 seconds. And it is in mils. Liters and mils.
4, 3, 2, 1.
That's 30 seconds. Oh, that's the last one,
Yeah.
Ninety mils.
090.
So 1 liter 90 mils.
1 liter 90 mils.
1,090 mils.
The last round is 1 liter 90 mils.
Okay, so with that run 4, now you can work out mils per second. Yeah. So you should now be able to calculate those three. You've got those 3 values, and you should be able to use that to solve the problem. 15 hectares, 2 liters per minute. 2 liters per hectare chemical. Any questions? Yeah? Okay, that's it. You go and finish whatever you need to do for your reports. And
Okay, Lord. The displacement rate, the time is constant, which is 30 seconds. So we're going to have four trial. First trial, which is after the 30 seconds that he sprayed, it takes about 1 liter 140 ml, and round 2, which is 1 liter and 90 ml, round 3, which is 1 liter 40 mil, and round 4, which is 1 meter 1 liter 90 ml. Thank you.